Hello and welcome to another of my Magic Road tutorials, and in this tutorial I'm going to talk about how to use the gold standard elevation data, LIDAR data, for your Magic Road. In one of my previous videos I showed how variable the elevation data can be from certain online route planning sites. I did show that for the Box Hill segment Strava was very good. However, it isn't always as good and sometimes it falls down, and it's nice to have an alternative. And the gold standard, as I say, is LIDAR. And it's difficult to get a hold of LIDAR data because the coverage isn't full across the world. It's rather patchy. But there are good sites to obtain the data, and one of them is Open Topography here, and another is the Environment Agency for the UK. Well, the data.gov.uk site. If you search EA LIDAR, you'll get the first link be this, and this LIDAR composite DTM 2017, that's just one subset of the data. What we want to do is we want to scroll down and view additional metadata and take a note of the coordinate reference system that's being used. That's important. Then you can click on the survey download and it will take us to a map where you can zoom in and select your region. So I've done that here. I've zoomed in to Box Hill and I've selected a region using this tool here. Let's see, it should be loading here, talking, and you'd use the region of interest tool and just click 1, 2, 3, whoops, oops, a daisy, and then double click, and that will highlight your region of interest. Now here I've already done this and it's loaded the possible options. So we've got digital surface map 2017 at 50 centimeter tiles. So that's everything that was there when the LIDAR survey was done. Trees, vegetation, whatever. That's useful to have. And then also the digital terrain map, which is ground only, and this is where you're going to be getting your elevation data from. Here we are at 50 centimeter tiles. So if I download those, that will give me a zip file, and within that are .arc files. And what you'll want to do is you'll want to highlight all the ARC files and drag them into your GIS program, and we'll see the GIS program that we're using at the moment. But I'll just move on to Open Topography and just show you the process of download here. If we go to Data, find Data Map, I can then zoom in on, say, Oregon here and Mountain Hood. And I've previously done this ride, and well, not in real life. I've always wanted it to do it in real life, but I've previously done it on Magic Roads, and I can highlight the region and it will show me the data that are available. So if I click the point cloud here, those are all the LIDAR points that are available, and it will tell me I've got too many to download. So you'll need to split the regions of interest to download all the data. And once you get that, you'll get that in LAS or LAS format. And I'm not going to go into the processing of those here, but it's relatively easy with LAS tools or Fusion in the GIS program. I'm just going to show you that we can unclick unclassified and we can just get the ground data. You will of course want all the other data just to check later on, but if we select a more focal region, and I think that includes the entire road, we have few enough points to download. So I usually click both LAS and LAS. I'm not sure why, there's no reason I should just choose one. And grid resolution, you can change it to 3 feet. You can change it all the way down to 1 foot. I don't know whether there's any advantage to that. I don't know the base resolution of this point cloud. But here, what it's doing is it's generating digital elevation models for you. And that's similar to the EA LIDAR site. You're just downloading ARC files, which you can just drag and drop into QGIS. And here you will be able to drag and drop these into QGIS as well. I'll just show you here the metadata, which you need to take a note of. So I got to that just by clicking on So clicking on full metadata here, and here we are. This is the coordinate reference system that's being used. Anyhow, once you have chosen your region of interest, selected what you want to download, you'll need to put in the job title, the job description, and your email address. Not your job title, the job you do every day, but the job title for this particular download job. And you click submit, it will process things and it will come up with the point cloud data. So right click, save link as, right click, save link as, don't just click, it may try opening in your browser. And these, you can save the link as, right click, save link as yet again, and you'll need a program such as 7-zip to drill down and get down to the to extract them from the zip archive and extract the TIFF file, which you can drag and drop into your GIS program. So these are digital elevation models, which you can use straight away with minimal processing. I'll show you what that looks like. Once it's drag and drop, if you're using the Environment Agency data, you'll have multiple tiles and you'll need to go to raster, miscellaneous and merge. So this is a raster layer that you've imported just by dragging and drop that DEM file. And here it is. It doesn't look like much, does it? So what I can do is I can hill shade this and I can see what it really is going to look like. So let's click Hillshade, and I will need to choose a file to save it as, save to file, and Hillshade ground TO. And yes, I wish to replace that because I'm doing this for a demo, and let's see what happens. Now the advantage of hill shading is you can see actually where you are, and if you've got the all the points, so you've got a digital terrain model, a digital surface model showing everything that's around, you can actually see, whilst we're waiting for this hillshade to complete, I'll just show you the advantage of the hillshade model. Here I can see nicely the trees, and you can see any trees and where your points are. And in some cases, not here, actually you can see the road really well, so it's nice to have definition around the road. So having the digital surface model is quite useful. And I can see that my GPX points are not on the road, these orange points. And again, we'll come back to that, but let's just see how our hill shading's doing. It's still not completed. Oh, here we are, it's completed. So let's close this, and you can see that we've got beautiful hill shading now, and you can see the road really easily. Right, this is my GPX track, and I'll tell you how I got there using this other set of data. So this is the what I did here was I used all this. It's taking a long time to load because I used all the LAS files and processed that with LAS tools. If you're going to do that, what you'll need to do is go to plugins and manage and install plugins, and you'll need to search for LAS tools, and you need to follow the instructions here. You do need to download them and install them on your C drive, as well as installing the plugin here. And also, if you don't want to use LAS tools, you can use Fusion. There are even more options to use, but you have to do the same here. Download plugin here, download the actual tools from their website, and then activate and configure it in the options window in the processing toolbox, which is here. And you get to the options with this spanner here, and you'll need to activate each plugin. And also, let's put GPX in our search and GPX segment importer. So what I can do now is, once I've got plugins installed, I can go to layer, add layer, and add vector layer. And here I choose my GPX points, Govy to hood test, let's say, and I can open that. And once you've opened that, it will overlay the points on your map. And what I found was looking at the digital surface model, where I could nice and easily visualize everything, I found that my points weren't on track. So what you do is you need to highlight your GPX file and click export, save features as. You will need to do this anyway, even if you don't want to edit your points, but you save it as oopsie daisy, ESRI shapefile, choose a name for it, hood points 1 meter, let's say, and make sure you're using the coordinate reference system that that your LIDAR data come in, and then you click OK, and that will import that as points from GPX here. Now, initially, those points will overlie the points that you've just copied them, so they'll be overlying. But if you want to move them back on the road, hit this little pencil button, then this movie button, and you can just click on the point and move it just like that. Now, I did miss out a little bit about the coordinate reference system. That's really important. You took a note of that when you were downloading your data. And here, if you go to settings and options, you need to set this up before you drag and drop your files into QGIS. So here and here, you need to set it to what you're using. And that stops you having to use a transform to transform your data to whatever else. Say my last project was using British National Grid, so maybe Box Hill. If I were to then drag and drop something that was in the Oregon GC Lambert coordinates reference system, it would need to perform a transform. And to avoid that, just set your workspace as the transform, as the CRS that you're going to be using first of all. Anyhow, back to our GPX data. So I've changed it to a shapefile. I've modified the points, and when I'm modifying the points, I'm going to make sure that if I were to interpolate some points here, the line between these would not cross off. If I had a point here, let's modify these points. If I had this point here and this point here, if I were to draw a line between, they would cross off the road. So if I were interpolating some points there, it would come off the road. So I want to avoid that. So when you're modifying your points, make sure you're going to get a nice result. And so what I can do is I can export these points as a GPX file. I haven't added any elevation data yet, but I can export, save features as, and we choose GPS exchange format. I choose a file name. I'm not going to bother changing that. And then I can choose point, and I can choose use GPS extensions. I choose yes, and force GPX path. And for the moment, that I'll just show you that this doesn't really work very well. What you get is a file that's incompatible with various programs. So what you'll want to do is just quickly change this with Notepad or similar. Let's see if I have Notepad up. Right, here we are. So we've got multiple extensions here, which are not very helpful, and the timestamps I've removed. I'll see if I can show you how to remove timestamps. Here we are. So I've removed the timestamps because they're not in order, and how I did that was Control F. This is Notepad++. It's extremely powerful. I would recommend using it. So I can use a regex here. You actually may find a much easier way to do this, because I'm actually looking at the options on GPX export on the QGIS, and I think I can find a way to avoid this. But for the moment, you can replace all these with nothingness. So I replace all, and they're all gone. So I'll exit that and not save. And with regard to these extensions, if you just load up this file in GPS Prune and export as GPX, it will remove those extensions. Once you've done that, you can then interpolate using GPX Interpolator, which I've shown you in a previous video. And if you choose resolution 1 meter resolution, that's probably overdoing it a little bit. In terms of, let's just talk about that. In terms of super high resolution and sampling points at really close intervals, you're never really going to use that on your turbo trainer, because no turbo trainer can react quick enough to elevation changes. Meter by meter is less than a second, and so you're going to introduce noise, and it's best to choose a larger interval between your data, so your turbo trainer can actually adjust to the elevation on time. Well, not on time, there's always a delay, but to make life easier for your turbo trainer and not to have unnecessary data. But for the moment, I'm just sticking with 1 meter. I'm oversampling, and here, if I choose 2, what I get, so that's 1 is linear interpolation, and most often you'll want to use that. But if I choose 2, then I can really get quite a smooth, beautiful result, and I'll show you that there. So it has interpolated a nice smooth curve all the way round, and that's a really lovely smooth curve, and you're going to get very good a very good, I'll switch back to the ground LIDAR data, you're going to get a very nice curve all the way around. Now I've got two hillshade maps here. I'll just okay, these are the data that I actually used, and what we're going to do, we've imported our GPX file again. We've copied it to a shape file with the appropriate coordinates reference system, and once we have the shape file, if I look, I've got hood points added from raster. Okay, hood points 1 meter, Guffey to hood 1 meter waypoints. Okay. So what I've done is, let's delete all these and see what I've got. Okay, so I imported my oh yes, edited to fit DEM. What I mean by that is I've edited it to fit the road. I've imported that now, and I want to save it as a shape file. So export as, save as, and I've got my shape file just above it. Now what I want to do is I want to get the LIDAR data to those points. So I want to transfer from this raster layer to the points, the vector layer. So what I need to search for in the processing toolbox is add raster values to points. And so I'll do that. I choose hood points 1 meter. That's the shape file that I copied from the GPX file. Then I'll choose the grid that I want to use. So it was output ground local gridding. That's the one I used actually for this particular case. And then bilinear interpolation. And then I'll want to choose a file to save it to. Oops, no. Added from raster. So there we are. And then I'll click run, and that will just add the elevation data to that shapefile. Now let's go to that shapefile added from raster, and if I right click and open the attribute table, I will see that the output mean t, that's the name of my digital elevation map that I used, the one that downloaded from Open Topography, and it will give you the output there. And the elevation will still be incorrect. Here it is correct because I've just done a useful little calculation here. I go to, I'll show you that again. I go to this calculator here, this little abacus, and I need to update existing field, elevation, and then I put output mean t, and then I think I can times 0.0348 to make it into, I've got an error here. No, I think that's fine. Yeah, output preview. Okay, so I'm just converting from feet to meters because most people are going to want to use meters. So let's just do that. And you can see it's edited that elevation track there. And let's look at the last point. Yep, again, second to last point. Yep, good. We're in meters. So once I've done that, I can save that, exit, and now I've got the elevation data added from this raster elevation map to my points, and I can just export that as a GPX file. Once again, just the same as before, save features as GPX exchange, follow all the steps as we did previously, and you have a GPX file. Again, you'll have some dodgy timestamps, so you can remove those using Notepad and add them again using GPS Babel, fit file repair, or an online tool. And the additional unused extensions, you can delete that by just popping it into GPS prune and export GPX. I think there are options you can choose from the export dialog that will avoid sending those. So let's have a look. You just choose, so let's see, track FID. Let's see, let's get rid of that. And then track segment and track SE1. And let's get rid of output mean total because we've actually changed that to our, okay. And if I get rid of time, there we are. Let's see that. I'll do that right now. And let's go into hood test. And we're going to use extensions, yes, and we're going to force track, yes, and we'll click file already exists, yes, file contains layers, fine, okay, and export to vector file failed. 3D measured point not supported in GPX. Okay, I'm sure I can get that working at some point. But for the moment, just use GPS prune, just use Notepad++. You can edit your file, make it compatible with all the programs you need, and boom, you've got LIDAR data from added to your GPX file. It will need some smoothing, especially if you've sampled at 1 meter intervals, as I have done here. I probably wouldn't recommend that. This is just a first go, really. I'd sample at a little increased interval. And I hope that helps. There's a lot to QGIS. There's a lot to using LAS and LAS files, which I haven't gone into here. The main takeaway point is to check your coordinate reference system and keep your coordinate reference system the same across all your layers. Okay, thank you for listening.